So today, our one main thing to knock out besides doing some review is this number 10. We didn't do the last example on the notes on page 5 already. So what we're going to do, but I'm going to ask nicely one more time. Thank you. Is what happens if I get into factoring and I don't find something they have in common, like this has X and this is just a number. Well, but it's not 3 terms, so I can't like slide and divide. Can I do the multiply other thing? So I'm going to show you 2 ways you can tackle this. You figure out which one you like. But here's what I am going to say. When you see what I call these little short ones, these binomials, normally it's because both of these things are perfect squares. Well, what does that mean? It means you can multiply something by itself and get that value. So like for x, I can multiply x by itself and get x squared. But you're like, well, 36. Now, if you know, cool. If not, 6. Otherwise, the multiplication charts you have, along the diagonal, those numbers that are shaded in are perfect squares. So if you went to 36 and followed it back to both the edges, you'd see that is 6 times 6. So, okay, we're here. Now what? So now I can either, there's a pattern that we can use, this a squared minus b squared thing, where you just take your 2 terms, and this is the same pattern every time. So if these are my a and b values, okay, if these are the values I'm looking at, it would be x plus 6. Oops, I didn't change my colors. X, too many colors, minus 6. And you're like, well, wait a minute. Like, if I multiply that out, I'm going to get like x's and stuff in the middle too. That's not going to work. But it actually does. And I'll show you why. This is not my other way of showing you how this works. It's just letting you see. If I do my FOIL, my first, and my outer, and my inner, and my last, the positive and negative 6x in the middle just cancel each other out. So that's how this ends up being the factored form, but I got to have one of each sign. Now, if you're like, even though I got the notes, I'm not sure I'm going to remember that if I see 2. Here's your other option. Do that in a different color. My other option is to stick a 0 in for the x. That's legal, okay? 0x would still be nothing. And then I could do it like we were doing Friday, where I could be like, all right, so let's see here. Multiplies to a negative. We saw before, if we multiplied to a negative, that means one's positive and one's negative. And then I need 2 numbers that multiply to 36 that are 0 apart. Well, multiply to 36, 6 and 6, whoops. 6 and 6 are 0 apart. I don't know, maybe. If you like the pattern, you can do the pattern. I'm just showing you 2 ways to do the same thing. Both of them would work. So you can pick when you run into that situation how you want to deal with it. I just see a lot of students normally when I have this problem, I'll see a whole lot of x minus 6, x minus 6. And I'll be like, nope, you're going to end up with the middle term. That's not going to work. And so when we're playing those, I'm going to find, let me see if I can find another one on the worksheet we're going to do today. Because, let's see, did I put them on here? Oh, I did. Okay, so what we're going to do, I'm going to jump over to the practice packet. Again, they're on the back table if you did not get one new one here. We're heading for Unit 3, Part 2 here. So page 17 is where we're going to be, but I'm going to flip to 18 for a minute. Because that's where a perfect square problem is going to show up. So, for instance, let's say we're doing number 19. And you're like, ooh, it's one of those mini ones and they don't have anything in common. What do you times by itself to get 4? 2. Okay, so 2, and I can't forget the variable. The variable's still part of this. What do I times by itself to get 9? 3. So now, all I got to do, if I'm using that pattern that we were just talking about, 2v is my first term in each set. 3 is my second term in each set. And for it to be negative, 1's plus, 1's minus. That's it. Just a couple of little details to work. But here's where you've got to be careful. When we were chatting Friday, we said the first rule always is there something all your terms have in common? Here's why I ask. Number 22, you're like, Hardy, they're both perfect squares. Let's go. Hang on. Does anything divide into both 4 and 64? Let's see here. Does 4 divide into 60? Oh, it does. So what's that mean? That means I can factor out the 4 that they have in common. And then I'm going to divide each of those by 4. And amazingly enough at this point, they're both still perfect squares. So here's the dilemma we can run into sometimes with this. And I'll show you how I would react to it on a quiz if this happened. Because it could. So that 4 that I took out is still there. It did not disappear. It did not get divided out. It just sits in front. And then just like we did on number 19, there's my first term, so 4n to start. There's my second term, 1 to end. 1 gets a plus, 1 gets a minus. And here's why I do that one every year. Because I'll have people that'll sit there and say, hey, they're perfect square. And they are. They'll be like, all right, 64n squared minus 4. I got this, Hardy. This is 8n, and this is 2. 2 squared is 4. 8 squared is 64. I took it off my chart. This is easy. I love this. And then they do this, and this, and then then they look at my answer key and they go, wait, what's going on here? And then I say, well, if you look at this, do those two have anything in common? And they're like, well, yeah, 2. I go, okay. So if I take a 2 out of just that pair and divide that out, and then I say, well, what about this pair? Well, it's still 2. Okay. And you start to see where I'm heading. 2 times 2 is 4. Thank you. And check out the answer we got up above. It's the same thing. But do I want to go through all that work to get there? Not really. Well, Hardy, what if I just left it like this? If it's on a quiz, you're going to get dinged for a half because that's not simplified. This is. So always look to see if there's something in common. All your terms have something in common for you to be able to get out of there because it's going to help you immensely. Just something to keep in mind. Well, that was a little late. Well, I'll give it in a minute. So, Hardy, back to the front for a minute. Do I have to go back to the front? Yeah. Well, no, I don't have to go back to the front. I can keep doing stuff back here. Okay. Oh, but do I want to be nice first, though? Hang on. Yeah, definitely nice first. Okay, let's be nice first. Back to the front. Okay. So once we check to make sure that everything, what's that? That they don't have something in common, like Those have x, but this doesn't. I can't take out an x. So this is the part, back again to Friday. I'm looking for two numbers that multiply to negative 40. And reminder, when I'm looking at the multiply numbers, if I want it to be negative, I got to have one of each sign. But now, I need these two numbers to be 3 apart from each other. Because again, when they're different signs, that's what we're looking for. So either I can do it in my head, I could start dividing in the calculator, or if I grabbed one of the charts in back, I could just go looking for 40s and then be like, hey, 8 and 5, they're 3 apart. That's the sign of the bigger number. Okay, this will always be the sign of the bigger number. That's another clue that's in there for us at the very beginning. And so that's it. I don't have to do anything else to this. That one's factored, that one's done. But that only works that quick if there's no number in front of your x squared. Well, Hardy, what if there is a number in front of x squared? Then, like, what do I do? Well, it depends. Here's what I mean by it depends. I got 2 last ones I want to do with you, because I might jump in on something else, but I think these 2 should do it. Before I start, I can do 5 with it there. 5, 55, and 120. Did they all have something in common? Yeah, let's test out 5. A lot of times that first number, there it is, that works. So we're going to bring the 5 out. Again, it's not disappearing. And we're dividing each of these by 5. And I did that over here with these. By doing that, I just saved myself a whole lot of work with really big numbers. Because now when I go to factor this, now it's back just like the one we did up here. This is my multiply number. This is my add, because now there's not a number in front of k squared. So I start looking for those clues. And I'm like, okay, everything is plus. So I don't have to think about signs. Everything is plus. So now I need a pair of numbers that multiplies to 24, but adds up to 11 because they're the same sign. And I'm like, 2 and 12? No. Let me try 3. 3 and 8. Yep, 3 and 8 will work. And if they're the same sign, it doesn't matter what order I put them in. If you did 8 and 3, that's fine. And you're done. So always check to see, can I get something out before I start? Like, for instance, you look at 4. I know I said I was doing 9 next, but this caught my eye. What do those two have in common? These two got something in common. Nope, no 6.
Oh, wait, that's not 6.
Okay, I was going to say, I can see how you thought it was that, though. So a B. So if I subtract a B from each of these, well, then I have no B's left over there. Well, Hardy, now what do I do? Like, where's the multiply and add? If this isn't squared anymore, that might be all you can do. Now, is that going to happen a lot? No, but it could happen some. So just something to be aware of. And the only other part that we haven't talked about today that we did Friday. Well, what happens if there's nothing in common and I still have a number in front of my x? Okay, we're going to turn it into something like the problem we had up here. So here's how this works. We're going to multiply that 5 over here to the 127. The numbers are going to get a little chunky here for a second. Nothing we can't work through, though. So 5 times 27 is 135. Oh, dear. You're like, seriously? You want me to come up with numbers that multiply up to that? Are you crazy? Maybe. It wouldn't be the first time I was that crazy. So I look and I'm like, well, wait a minute. My multiply number's positive. So if it's positive, it's going to be, ooh, there's two options. That's the option I want. I want negative and negative. So, okay, we got that piece. We're multiplying to 135, and the numbers are 24 apart. You're like, Hardy, this chart's only going up. Ooh. Ooh. Because you're like, well, wait, there's only one number on the chart. So let's see here. 15 and 9, that would add up to 24. Now, if, let's say the number wasn't on your chart, is there a possibility that you are going to have to start just dividing numbers in? Sometimes you may get decimals, so that's not real helpful. But you may have to just keep playing until you find that pair that'll add up. That's life with these. Sometimes we got to do that. But you're not done. Don't circle that. Why not? X times x ain't 5x squared. So that number you multiplied down before, we're going to undo it now. We're going to divide it back out. So here's how this works to finish. If it goes in nice, 15 divided by 5 is 3. Don't forget the sign though. So minus 3. But if it doesn't go in nice, we don't do the decimal. We do math enter to make sure that's the simplest form, and 9 over 5 is. And we just take that denominator number and we tuck it back in front of x. So there's my 5x squared. Just like we did on Friday, if you want to check, you can multiply the inside and the outside together. Negative 15 and negative 9 is negative 24. Yeah, that's going to work. And get to my solution. This is one of those topics that you just have to get in and be willing to make mistakes, have a pencil, scribble it out, try it again, scribble it out, try it again. Because if you don't, quadratics, it's not just going to be this unit. This is showing up a bunch second semester too. So we got to keep firing away at it. So what's Hardy suggest? At a minimum, you need to do odds or evens. I would say if you're having some struggle, I'd do everything. I have a key up here. It's not online. I know. At some point I will, but here's kind of where I come with things. I have a lot of you that do work, but when I'm posting videos and keys and notes, and then I still have people like doing swadoosh, it takes my incentive away to go crazy with this, especially. Yep. Especially when I'm old. Especially when you've got the ability, if you really want to, I know y'all got weapons of mass distraction, take a picture of it. It's not a bad thing. That's not illegal. Well, if I said it was, it would be, but I don't, because it's okay. Yeah. Yeah, I was going to say, anybody at any time, thumb up, take pictures. I'll smile with it and hold it if you want me to. I don't care.
Wait, can I get that?
Sure, I don't care. I'll do all sorts of kooky things. Ooh, do I still have... Wait a minute. Let's see. Do I have... Hang on. I might be able to make this even better. Hang on.
Okay, hold on.
If I'm being asked to do photos, I have to do this right. Now, hang on. Oh, there we go. Hang on. I'm here for... Oh, crap. I'm dropping things. Hang on.
I'm just waiting for the other one to see. Huh?
I got to do this correctly if I'm going to do
I
it.
mean, you get a photo of him holding it. Yeah. You got it from
Oh, I'll wait. No.
No signs upside down.
Oh. Yeah.
Sweet, okay. The front side?
Oh, wait, I got to get it where the...
Yeah.
Gotta have the bling showing. Okay.
Okay, back side? Sweet. Thank you, I appreciate it.
All right.
Do you have the answer from last week on Friday? Cure.
I should. Now let's see. Where is that? Let's find that.
Just your green
Oh, sure.
glasses. Yes. Oh my gosh, wait, hold on. Sorry. So he is drippy. Oh yes. You wanna see it?
Now imagine, oh boy, this is gonna be fun. This will be coming somewhere in December, I think, because we're getting to completing the square. I actually am going to attempt. I get more gun shy about doing this by the year. I actually wrote a rap to completing the square, and I usually do it in class with my full getup. So as I get older, I become less and less wanting to do that. So if I bail, it's on my YouTube channel. So I'll just play it and then hide under the table.
What do you be posting on your YouTube channel?
Huh?
What do you be posting on your YouTube channel?
Like 1,300 math videos.
That's it.
Yeah, that's all.
How many followers you got?
Like 500.
I was gonna say, he's a good amount of example.
I have, here's my thing that's terrible though. I have more followers in foreign countries than I do. I actually had about 5 years ago, I had a guy reach out to me. He goes, I'm just teaching my course by playing your videos. It was I think it was some European country. He was literally just using my videos to teach the course because they didn't have anybody to do it. I'm like, that's kind of cool. Okay.
So you're
I get paid?
My own students don't care, but the students overseas like me, so whatever. Well, I try. Okay, I gotta find that key. All right, let's see what I can do here. I know it's toasty today, or at least this is just me. It's always toasty in here. See, it used to always freeze in here, and I was like, why is it always flipping cold in here? But now it's not. So, okay, wait, I forgot to freeze that. Oh crap! I didn't take attendance, did I?
One.
Oh my god.